Welcome to the Tomorrow's World Today podcast. We sit down with experts, world-changing innovators, creators, and makers to explore how they're taking action to make tomorrow's world a better place for technology, science, innovation, sustainability, the arts, and more. On this episode, host George Davison, who is also the host of Tomorrow's World Today on the Science Channel, sits down with Stephen Johnson. Dr. Johnson is the director of the Space, Nuclear Power, and Isotope Technologies Division at the Materials and Fuels Complex at the Idaho National Laboratory. He discusses NASA's nuclear power systems, which support space missions in remote and hostile environments, such as the Moon and Mars. Dr. Johnson's work includes creating long-lasting, compact, and reliable power solutions for spacecraft, with a strong emphasis on innovation, collaboration, and quality to ensure success in harsh space conditions.
Well, welcome to our show.
Happy to be here.
All right. Well, I have some questions for you today, and I hope you'll just, share everything you can with our audience. And maybe we should start with, can you talk a little bit about what does Idaho National Lab Space Division do?
We do power systems for NASA in remote and hostile environments.
So a remote hostile environment would be, could you describe what that is?
Let's say on the Moon, on Mars, cruising by Pluto, cruising by Saturn, those sort of environments.
Yes. Now those are pretty harsh environments.
Yes.
So in your division, what does the future look like?
The future looks like lots of different applications of nuclear power equipment to help empower different space missions, whether it's going to Mars for a sample recovery mission, another launch out of the solar system, like a lot of people see the Voyager probes. Those are out of our solar system. There's a mission out there called Interstellar Probe, which is a mission that it's going to take them 50 years to get out there, and they need a power system that's going to work that long. That's the future. Wow.
So I imagine these power systems that you're talking about, these aren't big vehicles, are they?
No. Everything with NASA is very much about how small can you make it and how little can you make it weigh.
That makes sense. Because it's very expensive to shoot things up into space.
Very expensive, and it's all about mass and volume.
Mm-hmm. So then, can you talk about what your position is responsible for?
Yes. When NASA needs a power system to help enable a mission, and they've determined that a nuclear-powered power system is the best way to go, they contact the Department of Energy, and the Department of Energy turns to the Idaho National Laboratory and its other partner national labs to provide that power system. And typically we get that sort of call about 5 to 6 years prior to launch date, as they say. And we work very hard to make certain we get the right power system to the NASA customer in time, and that it's going to do what they want it to do.
All right, so let's walk this back a little bit, Steve. How did you get started on a course in your life to, going into this kind of work?
Okay, for me it started very, very early. I'm in my late 50s, so I grew up in the Apollo era. I was that kid that built that 2-foot-tall Saturn V rocket.
Yes.
That got an encyclopedia set called Above and Beyond that had all that neat NASA stuff and aeronautical stuff in it. And I tended to focus on, nerdy stuff, science and mathematics when I went through school. And that was my start back in the late 60s, early 70s. Graduated 1980, went into chemistry and mathematics, and later laser beams for doing analysis, but that was my start.
That's very interesting. So, but just so, the rocket world, that when I was in high school, I started a club there, and it was the Rocket Club, and it was so exciting. We would all build our rockets, and then on the weekend we'd go out and shoot them off, and our imaginations would just soar. So, that's interesting. Having things to think about or to give you inspiration when you're younger to shoot for, right?
Absolutely. And you can, I'm a firm believer in, you can never tell how things are going to finally come together later. The things that you do earlier in life that you think, well, this is okay for a little while, but if you retain that knowledge, when you come to what you really want to do, it all kind of blends together, and you never know what's going to be at the end of the pathway. You always need to remain engaged and learn what you can wherever you're at.
Well said. So how important would you say innovation is at the Idaho National Lab Space Division?
It's very important. When I look at you look at the Mars missions from 2002, Spirit and Opportunity, and when I first looked at the films from at that time, the Jet Propulsion Lab, I'm like, okay, how are you going to get this down? I looked at this three-dimensional triangular thing that was going to go down through the atmosphere, bounce around a whole lot, and pop open. There was a rover. I was like, there's no way that's going to work. And we delivered the heat sources that are on Spirit and Opportunity that worked for many years. And we later followed up with power systems for the Curiosity rover and the Perseverance rover. And again, I looked at that and I'm like, okay, you're coming down and you're slowing down from 24,000 miles an hour down to like 10 feet a second. I was like, you're kidding. That's not going to work. And you watch the films and then you watch the actual landing. And I thought, wow, what a neat thing to be part of.
Very much so. So figuring out how to make things like that happen there's a lot of innovation in trying to think differently, think outside the box.
Absolutely. You can't apply exactly the only things that you know that work on Earth to something that's going to be on another planet or orbiting another planet. You've got to think outside the box, and you got to check it out.
Isn't that interesting? I never really thought of it that way, because everything you have to think about out in space has to be in like space world, right? There's no gravity. There's so many unique things out there we don't even understand yet, and you have to try to envision that world and come up with products or solutions that let you kind of navigate it.
Absolutely the case, and specifically for what we do in Idaho, our power systems, one, there's not a backup on board. Two, once they're on the spacecraft and launched, there's no repairs or anything. Secondly, we basically certify them to work for 17 years. They take 7, 8, 9 months to get to Mars, and then they have to work for years and years after that. And you think about that, and there's some things that we do that are very quality-driven, little things, certified torque wrenches and all these things. And people go like, why are you doing it so rigorously? It's like, it's got to work for 17 years. And you've got a $2.5 billion space mission that if your part doesn't work right, it doesn't work at all.
It's a lot of responsibility.
It is, but it's also pretty damn cool when you get right down to it.
It sure is. That is exciting. All right, well, let's keep moving along here. So in your specific position, what would you say you're responsible for directly?
Okay, when the use of nuclear power is first thought about, they're interested in what can it do, what can't it do, when can you provide it, how much is it going to cost, those sort of basic questions. And as in my position, I'm that first contact with the Idaho National Lab. I'm there to say what we can do, what we can promise, when it can be there, and what kind of interaction we can have with NASA along the way. That's my job, which is to lay out the playing field, make certain we get the deliverables up front, the schedule, the cost profiles, get all the coordination done within the Department of Energy that I can do in my position, and that's why I'm there typically every spring when NASA does its budget planning, which goes out for us 7 years. I'm there to provide those estimates so that people can know what's available when they put out a announcement of opportunity, an AO for a mission. I'll be that last point of contact to say, yes, we can provide this, and we will be there. You don't have to worry about us. We are going to be a good partner.
All right, so in order to do that job, it sounds like you need quite a few different skill sets in order to be able to make a recommendation of that type, right? That you can achieve this kind of an outcome, and you do understand what the cost and all the parameters are going to be. So is it you? Do you work with a team? How does that function?
Okay, as far as providing the product, I work with other people at Oak Ridge National Lab and Los Alamos National Lab to make certain we have all the pieces and parts, as it were, along with our commercial partner for the power system. So we make certain we've got all the pieces and the parts that our production schedule will support that. So that's a coordination job. I'm also National Technical Director for Space Nuclear Power for the Department of Energy. So that is something that I know the right people to call to get the right information. So that's an important part. As far as the costing, I've done the costing for over the last decade. That's a coordination thing as well as making certain you know all the right people to call in all the right partner organizations. There's lots of little pieces and parts, and we've done this for 4 space missions now. It's knowledge of who the players are, what they can provide, the costs, factoring in if you need additional margin, and knowing who to contact down at Kennedy Space Center for the other pieces and parts that fit in later on. I've done that a few times now, and so that's what I do.
Sounds like a pretty big team and group of people you're pulling together.
The magic part is when you're in that last 4 months and you're down at Kennedy Space Center and you're down there with 100 people from the Jet Propulsion Lab or Applied Physics Lab, who's ever managing the mission, and you've got a couple, 3 dozen of your people delivering a power system, and you're fitting in with all the subcontractors down there at Kennedy. That is the greatest group dynamic exercise I've ever seen. It all culminates with watching a rocket go off. I mean, that's pretty way cool.
It is really cool. I mean, big inspiration. And to be a part of it, you must be very proud of yourself.
It's very satisfying.
Yes.
Because you're usually at the end of a 5 to 6 year spin up on it, and when you get to that point, it was a little bit more interesting this last launch, the July 2020 Mars 2020 Perseverance rover. We were all down there and everything, but of course Cocoa Beach was deserted. It was during the pandemic. We were down there April to July, and there was nobody down there if you weren't involved with the mission, not out and about.
Well, thank you for your contribution to making all this happen. And I'm sure somewhere along the way there were others that contributed to you. Did you have any mentors when you were, let's say, in high school or younger or even college that helped to start you on a course?
Several on the way. I'll focus maybe on some in the... Let's see, I had a chemistry teacher in high school. I had a couple of years of chemistry through him, and he was always somebody that was very inspirational, hard work, and taught me all the stuff that he could, and that was a nice launching board for college. And other people on the way, just work hard, learn what you learn, and don't worry about looking too far down the track. Just you've got a job, do your job well, and good things will happen. That was something when I went to the National Lab system. I had several good mentors. They all did it a little bit differently, but they were very inspirational, and it's fantastic now. If I can grab somebody who needs some mentoring now or needs some comments, I've had people come in, they're like, oh, okay, I don't know about this or this, and I'm like, hey, just, this is where you're at. Where do you want to go? Well, I'm not certain. I said, well, you're at a pretty good spot. Work hard, do well, and keep your eyes open. If there's something out there I can help you with, as far as a direction, a recommendation, I'm here to help you out, trying to give back a little bit.
Yes. It sounds like you really like what you're doing. So was it just a stroke of luck that you happened to find that? Or, how did that happen for you?
For me, kind of the magic moment was 2002. I was managing an electron microscopy lab, had a small group of people, and we were doing good work and working hard, and finally DOE came in. They said, hey, we've got this stuff in Ohio that due to the fallout from 9/11, we need to move somewhere else. And the lab looked around. They said, hey, you do something with plutonium-238. I'm like, yeah, I'm a PhD chemist. I manage a lab. We analyze samples with it. They said, oh, you're it. And so we were given 3 weeks to put together a $15 million proposal on how to move a medium-sized project that needed a new building and all this stuff. And I kind of walked away from that. I said, can I go to Ohio and look at this? They said, no, you can't do that. And so I called together a big meeting on Monday, and this is Friday, and I'm sitting there going like, wow, what am I going to tell people? So I spent the weekend with butcher block white paper sheets, 3 foot tall,
right,
sketching out stuff. And that was what I conducted the meeting with on Monday.
Mm-hmm.
And people were looking at me. I said, hey, we need this put together, buffed up, shined in 3 weeks. It ended up being a $15 million proposal that we sent out, and I knew all the right people to call, but there, some people were like, you've never handled something this big. Why? There was a lot of just suspicion that it was just an exercise, and we pushed it through. And within 3 months, we had the project coming our way, and then I got a whole bunch of learning experiences over several years.
I'll tell you, I can tell your experience because you said butcher block paper, and that's such a valuable asset, right? I mean, for all of you out there who don't know what that is, when you go into the butcher shop, that where you get your meats in the grocery, there's a very big spool white paper there, and it's like the greatest paper to draw out all your ideas, and it just goes on and on and on and on, so you can really get inspired and just keep going. And we've used plenty of butcher paper over the years around here. It's just funny to hear you bring it up. So let's chat a little bit about people in general. Do you believe anybody can be successful?
Yes, I do. You need to take if you're just sitting there and you don't know where you're going, think about what you enjoy doing.
Mm-hmm.
Don't be concerned about how much money you can make doing it. Think about something you truly enjoy doing, just for doing it. And once you've picked those 1 or 2 or 3, 4 things, and maybe it's just 1 or 2, take a look at it and talk to people in that field. See what you can do that maybe you can make money doing it. Again, trying to enhance my small talk capabilities on an airplane. I sat next to this guy, and he was there with, ripped out jeans and everything, and I was flying from Salt Lake City to Glenn Research Center in Cleveland, and he was going to Cleveland, and he was probably about 30 years old, and I said, so what do you do? He said, I do pyrotechnics. I'm like, really? I said, is that good to you? He said, I'm going into Cleveland, and he said, I'm doing this, and I just stared at him, and he said, yeah, a lot of the young guys, they go to school, they get all these degrees, they learn about chemicals. He said, but if they come and they intern with me, he said, within about 1 year, I can get them to a skill level where they're making 6 figures. And now this is the lead pyrotechnic guy for Beyonce and Jay-Z. And he was flying in for them to do their big shows in Cleveland a few years back. And I thought, okay, this guy, he's got it going on. He had just come back from L.A. visiting his family, his wife. And, he looked like somebody that was itinerant, whatever. But, no, he's like, no. He said, I can show you how to do the big pyrotechnics. I can do this. And I'm like, hey, you're working for Beyonce and Jay-Z? I'm like, yeah, you're probably doing pretty okay. And, but that was somebody who figured out what they wanted to do. He didn't have a college degree in anything. He just picked it up by having somebody teach him something and kept working on it. And he was at the top of his game. I thought that was pretty neat. So again, pick something that you like to do, focus on it, talk to people in the field. You can probably figure out a way to make a living doing it, maybe better than make a living.
Steve, it's great advice. If you're lucky enough to find what you like, it's not work, is it? It's like, it's intriguing and you want to go do it. You want to jump out of bed in the morning and go get started with what you're doing. I think some of the challenge is finding what you like, right?
Absolutely, but I've had other people on the way, other mentors tell me, they said, okay, you got degrees in this, figure out what you like to do, because they said at some point you may have that tough stretch where you're not making a lot of money, whatever else, and he said, if you're doing what you like to do, he said, you'll get through those tough stretches, but if you're doing something that you were only doing because you could make a lot of money at one point in time, and all of a sudden that's dried up or changed, then you don't have a whole lot to keep you going during the day.
Yes. Well said. All right, so let's shift back for a minute. We're going to go back to the nuclear energy, the nuclear area for a minute. What do you think the next big innovation will be in the nuclear industry?
Okay, so from my background, we also do developmental work in the application of nuclear reactors for space. If we ever want to get men to Mars and get them back again, we're going to need propulsion systems that are nuclear-based to get there. And that work has been ongoing for several years, but still is in its infancy. That's a neat field to work on. Or if we want to get men to have a colony on the moon, they're going to need power. Solar won't do it. Half the time you're at the moon, you're in the dark, 14 days at a time. So having a nuclear power plant on the moon would be truly neat. Those are things that are out there. They're under development. They're 10, 15 years off. Plenty of opportunity for somebody to jump in there and make a mark and learn something pretty neat and really contribute to that. So that's I think is a hot area. There are several areas where NASA is currently spending millions, tens of millions of dollars per year in, and NASA spends it within NASA, within universities, within private companies, lots of different venues that you can contribute to that. That's what I think is a important avenue going forward for nuclear power.
Nuclear power on the moon. That sounds so exciting.
I mean, one of the questions that came up recently, things probably nobody ever thinks about. Okay, if you're going to have a manned colony on Mars, what's it going to be constructed of? Okay, so people are trying to get samples back from Mars, because if you're going to go to Mars, I don't think we're going to be hauling bags of here in Portland cement up there and a whole bunch of water. So they're trying to take a look at the regolith, the soil of Mars, and figure out what's it made of and what can we add to it to essentially make Martian concrete. And although people may go, ick, it's like, okay, so what if you got on Mars, you've got the regolith, well, what's the other part? So they're using different forms of urine to try to be that liquid that they to make concrete, so they can actually build things on Mars. Because again, mass is everything, and you're not going to be hauling steel girders up there or slabs of preformed concrete. You need a way of making a permanent structure once you're there.
And water is very heavy, so we don't want to have to blast that up into space. So urine makes sense.
Yeah. So it's those are different aspects. There's lots of different aspects. If you're focusing on biology, they're looking at the different things that have lived on Mars in the past. So you don't have to be a rocket scientist to be involved with space stuff. Just kind of a take-home message there. There's lots of different angles. You need a way of, if you can think of a more efficient way of splitting, say, frozen water you may find on the moon or Mars to get oxygen and hydrogen, that's a fuel. That's another different angle. Lots of different angles that you can apply up to something that NASA's going to do on Mars or on the moon.
Steve, I can't thank you for sharing your wisdom with us today. Thank you for coming out.
Thank you for having me.
Thank you for listening to this episode of Tomorrow's World Today podcast. Join us next time as we continue to explore the worlds of inspiration, creation, innovation, and production. Discover more at tomorrowsworldtoday.com, connect with us on social media at TWT Explore, and find us wherever podcasts are available.